A silent, glittering tool bag orbits our planet, lost forever in the endless night. The stories of space are not just about equations and engine burns. They are a collection of hidden oddities and breathtaking wonders. By the end of this journey, you will know 30 of the strangest, most mind-bending truths hidden in the final frontier. We will uncover why the moon smells like spent gunpowder and how a day on Venus can outlast its entire year. The cosmos is far weirder than fiction, and every discovery raises a deeper mystery. What do you think is the most surprising secret the universe is still keeping from us? Before there was a dog named Laika or a chimpanzee named Ham, there was a humble fruit fly. In the closing days of 1947, a captured German V-2 rocket, its original purpose now repurposed for science, screamed upwards from a New Mexico desert launch site. Its precious cargo was not explosives, but a small sealed capsule containing a colony of common fruit flies. Scientists wanted to answer a fundamental and terrifying question: what would happen to living tissue when exposed to the intense radiation believed to exist beyond our atmosphere? They chose fruit flies for their simplicity, a short lifespan that allowed for rapid observation of generational effects, and genetic makeup that was easy to study. The rocket arced over 100 kilometers up, officially crossing the arbitrary boundary into space before the payload capsule separated and parachuted back to Earth. When researchers opened that capsule, they found the fruit flies alive and unharmed. This tiny, buzzing success was monumental. It was the first definitive proof that life, even in its simplest form, could not only reach space but could survive the journey and return. That single experiment, using insects you might swat away from a bowl of fruit, quietly launched the entire field of astrobiology and gave engineers the first green light to dream of sending more complex creatures and eventually us into the great unknown. While fruit flies proved life could survive the journey, the human body itself begins to change in profound and unexpected ways the moment it arrives. Floating inside the International Space Station, free from the constant pull of Earth's gravity, an astronaut will slowly begin to grow taller. This is not a trick of perspective, but a direct physical transformation. On Earth, gravity compresses the stack of spongy disks between the vertebrae in your spine, like a heavy weight gently pressing down on a spring. In the weightlessness of space, that pressure vanishes. The disks expand, the spine straightens, and the entire column can lengthen by as much as 2 full inches, or about 5 centimeters. Imagine the relief of finally having that extra bit of height you always wanted, but there is a significant catch. This new, elongated spine is not built for our world. The muscles that normally support your back begin to weaken and atrophy without gravity's constant resistance. This combination of a longer, less supported spine is a primary reason why many astronauts experience significant back pain during their missions, and the change is thankfully temporary. Upon returning to Earth, gravity goes back to work. Over the course of a few months, the spine gradually recompresses to its original length, often accompanied by that same familiar ache as the body readjusts to a planet that insists on holding you down. So an astronaut returning from a long mission is literally not the same height they were when they left, carrying a temporary souvenir from their time among the stars. This temporary height adjustment is a tangible reminder of how alien the space environment truly is, an environment where even the most basic tools of exploration must be rethought from the ground up. High above us, drifting silently in the perpetual sunlight of orbit, there is a satellite that looks like it was stolen from a king's treasury. Launched in 1965, the Lincoln Calibration Sphere 1 is not a complex piece of computing machinery or a powerful telescope. It is, quite simply, a hollow sphere of aluminum about 3 feet in diameter, and its surface is entirely covered in a shimmering layer of gold foil. Its mission was one of elegant simplicity, to serve as a perfect cosmic reference point. radar systems on the ground used to track satellites and space debris needed something with a precisely known size and shape to calibrate their instruments against. The LCS-1 was that perfect target, a gleaming, spherical bullseye whose radar signature could be predicted with absolute accuracy. By bouncing signals off this known object, engineers could fine-tune their equipment to better understand the fuzzier, more chaotic returns from other satellites. The gold foil was not for decoration, but for survival. It reflects sunlight and regulates temperature, protecting the sphere's delicate internal pressure sensors. And this beautiful, bizarre artifact of the early space age is still up there today, tumbling end over end in a high orbit. Because of its highly reflective surface and stable shape, it has become one of the brightest man-made objects in the night sky, occasionally flaring into view as a brilliant moving star. It is a monument to a very specific kind of genius, solving a complex technological problem not with more complexity, but with a ball of metal wrapped in gold. That golden sphere reflects a sun that never sets, but the surfaces it illuminates hold mysteries for all our senses. When the Apollo astronauts returned from their historic moonwalks, they brought back more than just rocks and photographs. They brought back a smell. After clambering back into the cramped lunar module and removing their helmets, the astronauts were greeted by an unexpected and powerful odor clinging to their suits and the dust that coated them. They described it consistently as the sharp, acrid scent of spent gunpowder or the ashy smell of a damp fireplace. This was the smell of the moon itself, or more precisely, of moon dust meeting earthly air for the first time in billions of years. The lunar surface is covered in a fine, jagged powder called regolith, created by eons of meteorite impacts pulverizing the rock. Unlike Earth sand, which is smoothed by wind and water, each grain of moon dust is a tiny, sharp shard with fractured edges. Inside the lunar module, sealed and filled with oxygen, these pristine mineral surfaces, primarily silicates, were suddenly exposed to a reactive gas they had never encountered. Scientists believe the smell was likely caused by these freshly broken minerals reacting with the oxygen in the cabin air, a process called oxidation, similar to the rapid burning of metal that creates the smell of a sparkler or, indeed, gunpowder. It was the scent of the moon's ancient, silent geology finally meeting a breath of our world, a sensory souvenir of a truly alien landscape now chemically changing before their eyes. That strange, metallic aroma was the moon introducing itself not as a distant light, but as a tangible, dusty place with its own forgotten chemistry. The scent of moon dust was a tangible whisper from an airless world, a place where our very notion of reality begins to break down. We often describe space as the ultimate silence, a perfect and eternal vacuum where no sound can exist. This is only half true. While the familiar pressure waves we call sound cannot travel through the near-nothingness between stars, space itself is far from mute. It hums with a hidden symphony, one we are deaf to without the right instruments. The void is filled with an extremely thin, superheated gas called plasma, where atoms have been stripped of their electrons. This sparse medium can carry something else, extremely low-frequency radio waves generated by colossal cosmic events. Our robotic explorers, like the twin Voyager probes, have been listening in on this secret radio broadcast for decades. Their instruments have captured the haunting vibrations of planetary magnetospheres, the roaring gusts of the solar wind slamming into interstellar space, and the pops and cracks of charged particles dancing along magnetic field lines. Scientists then take these inaudible radio signals and transpose them down into a frequency range our ears can perceive. The result is a library of eerie space sounds, a chorus of whistles, moans, and thunderous roars that sound like something from a science fiction nightmare. You can hear the magnetosphere of Jupiter, a giant protective bubble of magnetism, shriek and wail under the bombardment of its own volcanic moon, Io. It is a reminder that the cosmos is alive with vibration and energy, broadcasting its grand opera on a wavelength we were never built to hear but have learned to translate. That hidden cosmic symphony is a reminder of how much we rely on our machines to translate the universe for us, and how a single, simple mistake can send one of those machines spiraling into the void. During a routine spacewalk in November 2008, astronaut Heidemarie Stephanischen Piper was outside the International Space Station, performing maintenance on a gummed-up solar panel rotary joint. Her task involved cleaning and lubricating the mechanism, a messy job that required a specialized grease gun and a set of tools. She had brought these items with her in a large, white canvas tool bag, roughly the size of a carry-on suitcase. As she worked, she discovered that one of the grease guns had leaked, coating the inside of the bag and her tools in a sticky, viscous fluid. In the weightless environment, as she attempted to clean the mess with a dry towel, the entire tool bag, tools and all, drifted silently from her grasp. There was no gust of wind, no sudden jolt, just the slow, inevitable physics of microgravity. With a gentle push it had received, the bag began to float away, tumbling slowly into the blackness behind the station. She reached for it, but it was already too far, receding into the endless backdrop of stars. In an instant, a bag of common wrenches and ratchets became a new, independent satellite of Earth. Ground controllers quickly tracked the object, designating it with the catalog number 33442. For a time, this lost tool bag was one of the brightest pieces of space debris in orbit, its white fabric reflecting sunlight so powerfully that backyard astronomers could spot it with binoculars, a tiny, sad star trailing the real station across the twilight sky. It remained in orbit for almost a year, a monument to human fallibility, until atmospheric drag finally claimed it. In August 2009, it streaked as a brief, final fireball over the South Pacific, its mundane contents vaporizing into the same elements as the meteors it once mimicked. Our lost tool bag tumbled into a cosmos governed by laws that can seem perfectly orderly until you look closely enough to find the exceptions. In our solar system, there is a rule so common we take it for granted. Nearly every planet spins in the same direction, a counterclockwise rotation as seen from above the Sun's north pole. They all spin like tops spun from the same hand, a legacy of the swirling disk of gas and dust that formed them. Then there is Venus. Venus does not simply spin slowly, it spins backwards. This is called a retrograde rotation, a defiant clockwise whirl against the cosmic grain. The leading theory to explain this planetary rebellion points to a moment of unimaginable violence in the solar system's chaotic youth. Astronomers believe a colossal object, perhaps a protoplanet the size of Earth itself, slammed into Venus not long after it formed. The titanic impact was not a direct hit but a devastating, glancing blow. The force of this collision was so immense that it could have literally stopped the planet's original spin in its tracks and then, over millions of years, set it spinning in the opposite direction, like striking a top so hard it reverses. This ancient cataclysm set the stage for a reality that seems ripped from a dream. Because Venus now spins so slowly and backwards, the time it takes to complete one full rotation on its axis, what we would call a day, is an astonishing 243 Earth days. Yet the time it takes to complete one full orbit around the Sun, its year, is only 225 Earth days. This creates a truth that bends the mind. On Venus, a single day is longer than an entire year. The sun would rise in the west and set in the east, but you would wait over 8 months between sunrise and sunset, watching the star crawl across a hazy, scorched sky for longer than the planet takes to complete its journey around it. It is a world permanently out of step with every rhythm we know, a monument to the solar system's capacity for beautiful, bewildering chaos. Venus spins against the grain, a world of scorching paradox, but far out in the cold reaches of the solar system, Saturn's giant moon Titan hides a different kind of wonder, one that feels hauntingly familiar. When the Cassini spacecraft arrived at Saturn in 2004, it carried a small passenger named Huygens, a probe destined for Titan. For years, Cassini's radar pierced the moon's thick orange haze, and the images it sent back were nothing short of revolutionary. They revealed a landscape sculpted by rivers, dotted with shorelines, and filled with vast, dark pools that could only be one thing: lakes. But these are not lakes of water. On Titan's frigid surface, where temperatures plunge to -290 degrees Fahrenheit, water is frozen solid, harder than granite. The liquid that flows and pools there is methane, and to a lesser extent, ethane, simple hydrocarbons that exist as gases here on Earth. This discovery made Titan the only other place in our solar system, besides Earth, known to have stable bodies of liquid on its surface. Imagine standing on a pebbly beach, not of silicate rock, but of water ice as hard as stone, watching waves of liquid methane gently lap against the shore under a dim, orange sky. Cassini's radar even mapped the depths of one large sea near Titan's north pole, Kraken Mare, finding it to be over 1,000 feet deep in places. This is a full, active hydrological cycle, just with a completely different chemical ingredient. Methane evaporates from the lakes, forms clouds in the thick nitrogen atmosphere, and rains back down to fill the rivers and seas, carving channels and canyons in the icy landscape. This alien yet familiar geology hints at something even more profound. Where there is liquid stable over immense periods of time and a rich soup of organic molecules, the fundamental chemistry for life as we understand it can begin. Titan's methane is not a biological waste product as it often is here, but a potential starting point, a solvent for chemical reactions we can barely conceive. Scientists speculate about the possibility of exotic, methane-based life forms, microbes that might breathe hydrogen instead of oxygen and consume acetylene for energy. The Huygens probe, as it descended through the haze and landed with a soft thud on a damp, icy plain, sent back images of rounded pebbles smoothed by the flow of liquid, a sight that instantly connected this most alien of worlds to the riverbeds of our own home. It was a powerful reminder that the processes that shape planets are universal, even when the materials are utterly strange. Titan stands as a frozen mirror to Earth, a world where the recipe for creation uses entirely different ingredients, whispering that the universe's potential for wonder is far broader than we ever dared to dream. The thought of a world sculpted by alien rivers is breathtaking, but the reality of living in space is grounded in a far more immediate and practical challenge. Every single drop of water on the International Space Station is precious cargo, far too expensive and heavy to launch from Earth in the quantities needed for a crew of 6. So they make their own. The station's life support system performs a modern-day miracle, turning yesterday's coffee into today's. It is a closed-loop system that reclaims about 93% of all water on board, and its primary ingredient is human urine. The process is a marvel of engineering that begins the moment an astronaut uses the specially designed space toilet. The urine is not stored, but immediately funneled into the water recovery system. There, it undergoes a brutal purification gauntlet. First, distillation boils the urine, but in microgravity, bubbles do not rise, so the machine spins the liquid to create artificial gravity, forcing the purified water vapor to separate from a nasty brine. That vapor then moves on to a multi-stage filtration system that would put any home filter to shame. It passes through beds of porous materials that trap contaminants, then through a reactor that breaks apart any remaining organic molecules and viruses using a high-temperature catalytic process. Finally, iodine is added to prevent any microbial growth in the clean water tank. The system also captures every other bit of moisture in the cabin air, from the crew's sweat and breath to the humidity from their showers. All of it joins the same rigorous purification journey. The result is water so pure it actually lacks the minerals and flavor we're used to, so a touch of ionic calcium and magnesium is added back in. This recycled water is consistently tested and is often cleaner than the tap water in many cities on Earth. It is a psychological hurdle, certainly, but also a profound testament to human ingenuity, transforming a basic waste product into the very essence of survival. This technology is not just a space station quirk. It is the blueprint for every future long-duration mission to the Moon or Mars, where there will be no resupply ships. On those journeys, the courage to take a sip will be the same courage that carries us to new worlds. That same ingenuity that recycles water is focused on understanding forces of nature we could never hope to control, storms so vast they dwarf our entire world. For at least 350 years, a furious vortex has been churning in the clouds of Jupiter, a tempest known as the Great Red Spot. This is not a cloud formation as we know it, but a perpetual hurricane, an anticyclone of unimaginable scale. If you could pluck it from Jupiter's atmosphere and set it on Earth, the storm would easily swallow our planet whole, with room to spare. It is a landmark of our solar system, a constant presence in the giant planet's southern hemisphere, spinning counterclockwise and painted in shades of brick red and salmon pink by complex chemicals churned up from deeper layers. Yet this ancient, seemingly permanent feature is undergoing a profound change. When astronomers first began telescopic observations in the 1800s, they measured the spot to be over 25,000 miles wide, large enough to fit 3 Earths side by side. The Voyager flybys in 1979 showed it had shrunk considerably, and now, thanks to continuous monitoring by the Hubble Space Telescope and the Juno spacecraft, we have a startling time lapse of its decline. Over just the past few decades, the storm has been steadily constricting, not just in width but also in height, becoming more circular and compact. Today, it measures about 8,000 miles across, still larger than Earth, but only just. The rate of shrinkage is accelerating, and the reasons are a deep puzzle. It could be due to interactions with smaller eddies and storms, which act like cosmic buzzsaws, whittling away at its edges. Or perhaps internal turbulence is dissipating its energy. Some scientists even speculate that we are witnessing the final centuries, or even decades, of a storm that has raged since before the invention of the telescope. Will the Great Red Spot one day simply unravel and vanish, leaving Jupiter's face forever changed? Or will it stabilize, finding a new, smaller equilibrium in the planet's chaotic atmosphere? Every new image from Juno, showing the intricate swirls and deepening red of its cloud tops, is a snapshot of a cosmic giant in transition, a reminder that even the most enduring features of our solar system are not eternal, but participants in an endless, dynamic dance. While Jupiter's giant storm is a spectacle of unimaginable scale, some of the most profound truths in the cosmos are revealed not in vastness but in simple, quiet moments. On the gray, dusty plain of the Moon, at the edge of a crater named Hadley, Apollo 15 commander David Scott performed one of the most elegant experiments in the history of science. With a television camera broadcasting live back to Earth, he held out his hands. In his right glove, he grasped a 1.32 kilogram aluminum geological hammer. In his left, he held a 30-gram falcon feather, a tribute to the mission's call sign. He raised them to the same height, his arms spread wide against the black sky. Then he simply let go. In the airless silence of the lunar vacuum, with 600 million people watching, the hammer and the feather struck the regolith at the exact same instant. A plume of fine dust puffed up around them. Commander Scott's voice came through the static, clear and triumphant. He said, "How about that? This proves that Mr. Galileo was correct in his findings. That simple act was a direct validation of a principle Galileo Galilei had theorized nearly 400 years earlier, a truth that Earth's thick atmosphere constantly hides from us. Gravity accelerates all objects at precisely the same rate, regardless of their mass or composition. On Earth, a feather flutters and drifts because air resistance pushes against its large surface area, while a hammer slices through with ease. But remove that air, create a perfect vacuum, and the only force acting is gravity itself. The Moon, with its 1/6 gravity and no atmosphere, was the perfect laboratory. In that pristine environment, there was nothing to slow the feather, nothing to give the hammer an advantage. They were both in freefall, governed solely by the Moon's gravitational pull, and so they fell in perfect unison. That iconic piece of footage is more than a historical curiosity. It is a visceral, beautiful demonstration of a fundamental law of the universe. It shows that beneath the complexity of our world, there exists a stark and elegant simplicity, a rule so pure it can be proven with tools you might find in your own garage, provided you have an entire moon to perform the test. Galileo's hammer and feather fell together under a simple law, but the universe often conceals treasures of unimaginable luxury within its most basic rules. Astronomers have discovered a world that could be the ultimate cosmic jewel, a planet literally made of diamond. Orbiting a sun-like star called 55 Cancri, about 40 light-years away, lies a super-Earth named 55 Cancri e. It is a scorching, hellish world twice the size of Earth and 8 times its mass, locked in an orbit so tight that a single year lasts just 18 hours. Its surface is likely a bubbling ocean of molten lava, with temperatures soaring above 4,000 degrees Fahrenheit. But the true wonder lies beneath that fiery crust. Spectroscopic studies of its host star revealed something extraordinary, an unusually high ratio of carbon to oxygen. This chemical fingerprint suggests the planet that formed from that same stellar material is not a rocky world of silicates like Earth, but a carbon-rich world. Under the immense pressures found deep inside such a massive planet, carbon is forced into a crystalline structure. In other words, a significant portion of this planet's interior, perhaps a layer hundreds of miles thick, could be one solid, continuous diamond. Picture a core of glittering crystal the size of a world, hidden beneath a perpetual storm of incandescent rock. The challenges of confirming this are immense. We cannot drill into a planet 40 light-years away. The evidence is indirect, based on models of planetary formation and the observed chemistry of its star. But if the models are correct, the sheer scale of the diamond is mind-boggling. Attempting to put a monetary value on it is a futile, though fascinating, exercise. Based on current diamond prices and the estimated volume, its worth would be a number with more than 30 zeros, a figure that dwarfs the entire global economy countless times over. It is a treasure utterly beyond reach, not just in distance but in concept. This glittering world is a stark reminder that the ingredients for creation are scattered unevenly across the galaxy, capable of forging worlds of water, of iron, and on rare, spectacular occasions of pure crystallized carbon. It is a monument to cosmic alchemy, where the same element in a pencil's graphite can, under the right stellar pressure, become a planet-sized gem. A planet of diamond is a cosmic treasure chest, but humanity has already sent a different kind of treasure sailing into the void. Attached to the sides of the twin Voyager probes, each launched in 1977, are 12-inch gold-plated copper discs, perhaps the most ambitious messages in a bottle ever conceived. These are the Voyager Golden Records, time capsules of Earth crafted for an audience we may never meet. Their covers are etched with scientific pictograms, a cosmic instruction manual written in the universal language of physics and mathematics. A diagram shows the hyperfine transition of neutral hydrogen, the most common element in the universe, providing a fundamental unit of time and distance. Another illustrates the location of our Sun relative to 14 pulsars, the rapidly spinning corpses of dead stars whose precise radio pulses act as galactic lighthouses, giving a map and a timestamp to our corner of the Milky Way. The most poignant etching is a simple diagram showing how to play the record, with a stylus cartridge thoughtfully included in the protective casing. The record itself is a phonograph, an analog technology chosen for its simplicity and durability over billions of years in interstellar space. Its contents are a breathtaking snapshot of a planet and its people. There are 115 images encoded in analog form, depicting everything from mathematical definitions and DNA structures to scenes of human families, cities, and natural wonders like the Grand Canyon. The audio portion begins with greetings in 55 human languages, from ancient Akkadian to modern English, and even the haunting song of the humpback whale. Then comes a 90-minute symphony of Earth, a curated selection of music spanning cultures and centuries, from Bach and Beethoven to Chuck Berry, and traditional melodies from Senegal and the Solomon Islands. There are the sounds of a heartbeat, laughter, a mother's kiss, wind, rain, and the crackle of fire. The record's creators, led by astronomer Carl Sagan, made no attempt to hide our flaws or our conflicts, instead offering a hopeful, honest portrait of a young, curious species reaching out to say, "We were here." The Voyagers, now in interstellar space, will likely outlive our sun, carrying this golden whisper of our civilization on a journey that has no end. While the Voyager records carry our warmest greetings into the interstellar chill, humanity has created a far deeper cold right here in our own cosmic neighborhood. The coldest known place in the entire universe is not in the dark void between galaxies, but inside a small, humming metal box aboard the International Space Station. This is the Cold Atom Laboratory, a physics facility that routinely creates temperatures just a fraction of a billionth of a degree above absolute zero, the theoretical point where all atomic motion stops. To achieve this unimaginable chill, scientists do not use a giant freezer, but a precise cage of lasers and magnetic fields. They begin with a cloud of rubidium or potassium atoms floating in the station's microgravity. First, they blast these atoms with lasers from all directions. Photons of light carry a tiny push, and by tuning the lasers perfectly, they act like a thick, luminous syrup, slowing the frantic motion of the atoms, which is what we measure as heat. This process, called laser cooling, can already bring the atoms to within a whisper of absolute zero. But the real magic happens next. The slowest, coldest atoms are transferred into a magnetic trap where they are held in perfect isolation, away from the warmth of the station's walls. Here, something extraordinary occurs. The atoms, now barely moving, lose their individual identities. Their quantum waves, usually far too tiny to notice, begin to overlap and merge. They coalesce into a single, giant superatom, a state of matter known as a Bose-Einstein condensate. In this bizarre form, matter stops behaving like particles and starts acting like a wave. You can see interference patterns, ripples of probability with your own eyes. The microgravity of the station is crucial because on Earth, gravity would pull these ultra-slow atoms down and they would hit the bottom of the chamber before scientists could study them. In orbit, they can hold these fragile condensates for minutes at a time, observing quantum phenomena on a human scale. This isn't just about breaking a temperature record, it is about building a new kind of quantum playground. By studying matter in this state, researchers are testing the fundamental laws of the universe, developing ultra-sensitive sensors for gravity and dark matter, and paving the way for quantum computers of unimaginable power. The coldest spot in existence is not a dead, empty place, but a laboratory buzzing with the quiet, coherent hum of atoms in perfect sync, a window into a reality where the rules are written in waves. The coldest atoms ever known exist in a perfect, silent quantum state, but step outside that laboratory box and the universe offers a different kind of beauty, one painted across alien skies. If you could stand on the rusty plains of Mars as its thin atmosphere dims, you would witness a sunset that defies every earthly expectation. While our own sunsets blaze with fiery oranges and deep reds, a Martian sunset is a haunting, serene spectacle of blue. This reversal of color is a gift of dust. Here on Earth, our thick atmosphere is filled with tiny nitrogen and oxygen molecules. When sunlight streams through at a low angle, these molecules scatter the shorter, blue wavelengths of light in all directions, which is why our daytime sky is blue. By sunset, that blue light has been scattered away from our line of sight, leaving the longer red and orange wavelengths to travel straight through to our eyes. Mars flips this entire process on its head. The Martian atmosphere is incredibly thin, but it is perpetually filled with exceedingly fine dust, particles of iron oxide that are just the right size. These minuscule dust grains are superb at scattering longer wavelength red light out into the sky, bathing the landscape in a coppery glow during the day. When the sun dips low, the light has to pass through a much thicker column of this dusty air. The red light is scattered away sideways, and what finally reaches your eyes is the remaining blue light, concentrated and pure. The rover's Curiosity and Perseverance have sent home breathtaking sequences of this phenomenon, their cameras watching the sun shrink into a brilliant blue-white jewel against a twilight sky shaded in muted grays and pinks. To see the images side by side is to understand how profoundly a world's character is written in its air. Our sunsets are a warm farewell, a comfort. The blue dusk of Mars is a quiet, alien mystery, a reminder that even the most familiar daily rhythms can become something entirely new on another world. Venus does not simply spin slowly, it spins backwards. This is called a retrograde rotation, a defiant, clockwise whirl against the cosmic grain. The leading theory to explain this planetary rebellion points to a moment of unimaginable violence in the solar system's chaotic youth. Astronomers believe a colossal object, perhaps a protoplanet the size of Earth itself, slammed into Venus not long after it formed. The titanic impact was not a direct hit, but a devastating, glancing blow. The force of this collision was so immense that it could have literally stopped the planet's original spin in its tracks, and then, over millions of years, set it spinning in the opposite direction, like striking a top so hard it reverses. This ancient cataclysm set the stage for a reality that seems ripped from a dream. Because Venus now spins so slowly and backwards, the time it takes to complete one full rotation on its axis, what we would call a day, is an astonishing 243 Earth days. Yet the time it takes to complete one full orbit around the Sun, its year, is only 225 Earth days. This creates a truth that bends the mind. On Venus, a single day is longer than an entire year. The sun would rise in the west and set in the east, but you would wait over 8 months between sunrise and sunset, watching the star crawl across a hazy, scorched sky for longer than the planet takes to complete its journey around it. It is a world permanently out of step with every rhythm we know, a monument to the solar system's capacity for beautiful, bewildering chaos. That blue Martian twilight fades over a silent, dead world, but back on our own living planet, there exists a place of final rest for the machines that visit such distant shores. Far out in the empty expanse of the South Pacific Ocean, over 1,600 miles from any speck of land, lies the loneliest spot on Earth. This is the oceanic pole of inaccessibility, but you might know it by a more evocative name, Point Nemo. On a map, it is a coordinate, a precise mathematical point in the water farther from continents and islands than anywhere else. Its nearest neighbors are the uninhabited Ducie Atoll to the north, Easter Island to the northeast, and Antarctica to the south, all impossibly distant horizons. This profound isolation is exactly why space agencies around the world have chosen Point Nemo as the official cemetery for spaceships. When a large spacecraft like the Russian Mir space station or one of the many robotic cargo ferries reaches the end of its life, engineers cannot simply leave it in orbit. It would become a dangerous, uncontrollable piece of debris, threatening active satellites and the International Space Station. Instead, they plan one final, fiery journey. Using the last of their fuel, these veteran vehicles are guided into a controlled re-entry, targeting the vast emptiness around Point Nemo. As they scream back into the atmosphere, friction heats them to thousands of degrees, tearing them apart. What does not vaporize completely rains down as molten metal fragments into the ocean depths below. Over 300 spacecraft, including more than 140 Russian resupply ships and the 600-ton bulk of Mir, now rest on the dark, silent seafloor here over 2 miles down. No light reaches that depth, and the nearest humans are often the astronauts passing overhead in the space station, themselves 250 miles up. It is a poignant and practical solution, a remote graveyard where our most advanced technology returns to the planet that built it, sinking into a darkness as deep and unknown as the space from which it came. The silent graveyard of Point Nemo lies in utter darkness, yet some of the solar system's greatest secrets are hidden not in shadow, but in brilliant, soaring light. Far beyond Mars, orbiting the ringed giant Saturn, a small, icy moon named Enceladus performs a spectacle that redefined our search for life. For years, the Cassini spacecraft studied Saturn's family of moons, but when it turned its instruments toward Enceladus in 2005, it captured something no one expected. Streaming from the moon's south pole were enormous, glittering plumes, towering hundreds of miles into space. These were not clouds of inert dust, but continuous geysers, violently erupting from deep fissures in the ice known as tiger stripes. Cassini flew right through them, and its sensors were drenched. The plumes were composed primarily of water vapor, ice particles, and a surprising cocktail of simple organic compounds like methane, carbon dioxide, and ammonia. The implication was staggering. These geysers could not be powered by a small, isolated pocket of water. Measurements of the moon's slight wobble as it orbited Saturn revealed the truth. Enceladus harbors a global, liquid water ocean, sealed beneath an icy shell perhaps 20 miles thick. The gravitational tug of Saturn squeezes and flexes the moon's interior, generating enough heat to keep that vast subsurface sea from freezing solid. At its south pole, where the ice is thinnest, the immense pressure from this hidden ocean forces water up through the cracks, where it instantly flash freezes into a magnificent, icy spray against the vacuum of space. The most breathtaking images show these plumes backlit by the sun, transforming them into a delicate, luminous fountain of 1,000 rainbows, a frozen banner announcing the ocean below. This makes Enceladus one of the most promising places to look for life beyond Earth. We have a liquid water ocean, a source of heat, organic chemistry, and mineral-rich rock at the seafloor that could fuel microbial ecosystems, much like hydrothermal vents in our own deep oceans. Cassini's final, daring dive through the plumes tasted the spray directly, confirming the presence of molecular hydrogen, a key chemical energy source for certain microbes. We did not need to drill through miles of ice. The moon itself was offering us a sample of its hidden sea, shooting it into the heavens for us to catch. Enceladus is no longer just a frozen ball of ice. It is an active, breathing world, holding its ocean up to the light and asking us one of the most profound questions we can possibly ask. What might be swimming in the dark, warmed by the heart of a tiny, distant moon? That hidden ocean on Enceladus is a testament to how our robotic eyes have transformed the unknown into a place of profound possibility. But 3 years before Cassini launched, the greatest eye ever sent into orbit was blinded at birth. The Hubble Space Telescope, a project decades in the making, finally reached space aboard the Space Shuttle Discovery in April 1990. The world held its breath, awaiting the first crystal-clear images of the universe, free from the distorting shimmer of Earth's atmosphere. Instead, the pictures that came back were a heartbreaking blur. A star, which should have been a sharp point of light, was a fuzzy, useless smudge. The problem was traced to a catastrophic error in the telescope's primary mirror. During its polishing, a measuring instrument had been misaligned by a distance thinner than a human hair, about 1/50th the width of a sheet of paper. This microscopic flaw meant the mirror's curvature was off by a minuscule amount, but for an instrument designed to see to the edge of the observable universe, it was a disaster. The most expensive and sophisticated telescope ever built was nearsighted. The images were still better than any ground-based telescope could produce, but they were a pale shadow of Hubble's promised power. The project and NASA reputation seemed to hang in the balance, yet in that moment of profound failure, one of space exploration's greatest triumphs was born. Engineers and scientists refused to give up. They diagnosed the exact error and designed a set of corrective optics, a kind of sophisticated pair of glasses for the telescope. The solution was called COSTAR, the Corrective Optics Space Telescope Axial Replacement. Installing it would require the most complex series of spacewalks ever attempted. In December 1993, the crew of Space Shuttle Endeavour embarked on a daring repair mission. Over 5 grueling days of extravehicular activity, astronauts performed what amounted to orbital brain surgery. They captured the 13-ton telescope with the shuttle's robotic arm, opened its giant doors and swapped out instruments. They carefully slid the telephone booth-sized COSTAR unit into place, its array of tiny mirrors precisely positioned to intercept the light from the flawed primary mirror and refocus it. The mission was a breathtaking ballet of precision, with astronauts working in bulky gloves to handle hundreds of tiny screws and connectors, any one of which could have doomed the telescope if lost to the void. The moment of truth came weeks later, after the shuttle departed and engineers began the painstaking process of recalibrating the revived telescope. The first new images arrived, and they were nothing short of miraculous. A before and after picture of the core of the galaxy M100 tells the entire story. The before image was a vague, grayish cloud. The after image was a stunning revelation, a brilliant, sharp core surrounded by distinct knots of stars and dust. Hubble could see, the fix was so perfect that the telescope not only met its original design specifications, it exceeded them. That mission transformed Hubble from a symbol of costly failure into an icon of human ingenuity and resilience. It taught us that in space, no problem is truly final if we have the courage and creativity to solve it. The blurry vision was cured, and with its new clarity, Hubble would soon begin showing us the universe in colors and details we had only dreamed of, unveiling cosmic nurseries, colliding galaxies, and the deep fields that contain thousands of galaxies in a patch of sky the size of a grain of sand held at arm's length. The disaster had been rewritten into a legend, proving that sometimes our greatest leaps forward begin with a stumble, and that the view is always worth the struggle to see clearly. Hubble's clear vision now watches over a celestial environment growing more dangerous by the day. Orbiting our planet is a silent, invisible storm of our own making, a cloud of shattered metal and frozen fuel traveling at speeds that defy comprehension. We call it space debris, and it is the forgotten fallout of our exploration, everything from dead satellites and spent rocket stages to the fragments of old collisions, and even a lost glove or a stray bolt. The real danger lies not in their size but in their velocity. To stay in orbit, an object must travel at around 17,500 miles per hour. At that speed, a single chip of paint, no larger than a grain of sand, carries the kinetic energy of a bowling ball thrown as hard as a professional athlete could manage. For a spacecraft or an astronaut on a spacewalk, such an impact is not a scratch, it is a puncture. A marble-sized sphere of aluminum striking at orbital velocity hits with the force of a hand grenade. The windows of the space shuttle were routinely replaced after missions because of tiny pits carved by microscopic debris. This reality has given rise to a terrifying theory known as Kessler syndrome, named for the NASA scientist who proposed it. The concept is a cascade of destruction. One collision between two sizable objects like old satellites doesn't just create two wrecks, it creates thousands of new fragments, each a new bullet in orbit. Those fragments then dramatically increase the probability of further collisions, which in turn create even more debris. In the worst-case scenario, this chain reaction could create a dense belt of shrapnel around Earth, making certain orbits so perilous they become unusable for generations, effectively trapping us on our own planet. This is not science fiction. We have already seen warning signs, like the 2009 collision between an active American communications satellite and a defunct Russian one, which added thousands of trackable pieces to the orbital junkyard. Today, networks of ground-based radars and telescopes constantly track over 30,000 objects larger than a softball, but millions more smaller pieces are untraceable. The International Space Station regularly performs debris avoidance maneuvers, shifting its orbit to dodge known threats. Engineers armor critical components with multi-layer shielding, called Whipple shields, designed to vaporize an incoming particle before it can penetrate the hull. Looking forward, the cleanup has begun in earnest. Companies and agencies are testing concepts like harpoons, nets, and robotic arms to capture large derelict satellites and drag them down to burn up in the atmosphere. There are even proposals for giant lasers to nudge smaller fragments out of orbit. Every new satellite launched now must have a plan to deorbit itself at the end of its life. We are learning the hard way that the space around our planet is not an infinite dumping ground, but a fragile shared highway that requires careful traffic management. The legacy of our ascent must not be a cage of our own making. The orbital debris we create is a danger of our own making, but another, far more ancient and inevitable change is unfolding in the sky above us. Our moon is in a slow, steady retreat. Each year, the distance between Earth and its companion grows by about 1.5 inches, the width of your thumb. This tiny annual drift is the result of a gravitational tug of war that has been raging for billions of years, driven by the ocean's tides. As Earth rotates, its massive oceans bulge slightly toward the moon, pulled by lunar gravity. But because Earth spins so much faster than the moon orbits, this watery bulge is actually dragged a little bit ahead of the moon itself. That forward-pulled mass of water exerts its own tiny gravitational pull on the moon, giving it a gentle but constant nudge, like a parent pushing a child on a swing. This nudge transfers a little bit of Earth's rotational energy to the moon, boosting it into a slightly higher, slower orbit. The process is incredibly slow, but over cosmic time, the effects are profound. When the moon first formed from a cataclysmic impact over 4 billion years ago, it was perhaps 10 times closer, looming huge in a sky that was ablaze with volcanic activity. A day on Earth back then was only about 5 hours long. As the moon stole Earth's spin energy and pushed outward, our planet's rotation began to slow and our days grew longer. This celestial dance is still ongoing. In another few 100 million years, the moon will have drifted far enough away that it will no longer be able to completely cover the sun during an eclipse. The perfect alignment that creates the breathtaking spectacle of a total solar eclipse, with the sun's fiery corona visible around the moon's black disk, will become a thing of the past. Future inhabitants of Earth will only see annular eclipses, where a ring of sunlight remains visible around the moon, a beautiful but different kind of show. The moon's retreat is a clock ticking in the sky, a reminder that even the most permanent-seeming features of our world are participants in a slow, graceful, and irreversible cosmic ballet. The moon's slow retreat reshapes our sky over eons, but another world bears scars of geological forces that dwarf anything on Earth. Mars, the rusty neighbor we often picture as a quiet desert, is home to a mountain that defies all earthly comparison. This is Olympus Mons, the largest volcano in the solar system, a monument of such staggering scale that it redefines our understanding of what a mountain can be. To stand at its base would be to lose the summit to the curve of the planet itself. Olympus Mons is not merely tall, it is colossal. It rises 16 miles or about 25 kilometers from the Martian plain. That is nearly 3 times the height of Mount Everest, but its true wonder lies in its breadth. The volcano is a shield volcano, built from countless gentle eruptions of low-viscosity lava that spread out in all directions over millions of years. The result is a slope so gradual you would barely perceive you are climbing, yet its footprint is almost incomprehensibly vast. From edge to edge, Olympus Mons spans 374 miles, roughly 600 kilometers. If you could transport it to Earth, it would completely cover the entire state of Arizona or the nation of France. Its summit caldera, a complex of collapsed craters, is 50 miles across, large enough to swallow several major cities. The entire Hawaiian island chain, home to Earth's own mighty shield volcanoes, could fit neatly on its flanks. So why did Mars allow such a behemoth to form, while Earth has nothing even remotely close? The answer lies in a fundamental difference in planetary geology. Earth has active plate tectonics. Our crust is a jigsaw puzzle of shifting plates. As a volcanic hotspot pushes magma upward, it builds a volcano, but the moving crust eventually drags that volcano away from its source of magma, limiting its growth and creating chains of islands like Hawaii. Mars, however, has a static, single-plate crust. For perhaps 1 billion years or more, a single, stationary hotspot beneath Olympus Mons kept pumping lava to the exact same spot on the surface. With no tectonic plates to shift it away, the volcano just kept growing layer upon layer, eruption after eruption, into the solar system's most imposing landmark. Orbital images present a humbling view. Olympus Mons is so wide that its full profile can only be appreciated from space, a vast circular bulge that dominates an entire region of the planet. Its edges are marked by cliffs that tower miles high, where the weight of the mountain caused the Martian crust to slump. To look upon it is to witness the patient, relentless power of a world that once raged with fire, now frozen in time, a silent titan waiting for no one. The immense, silent volcanoes of Mars stand as monuments to a world without motion. But the human body, thrust into motionlessness, faces a more immediate and disorienting challenge. For roughly half of all astronauts, the first few days in orbit are marked by a miserable and unexpected ailment, space adaptation syndrome, more commonly known as space sickness. It is a profound sensory rebellion. On Earth, your sense of balance is a delicate partnership. Your inner ear, a labyrinth of fluid-filled canals, constantly tells your brain which way is down based on how that fluid settles. Your eyes confirm this with visual cues from the horizon and the rooms around you. In the weightlessness of space, that partnership shatters. The fluid in the inner ear floats freely, sending chaotic, confusing signals to the brain that suggest you are tumbling or spinning, even when you are perfectly still. Yet your eyes see your fellow astronauts floating calmly, or the steady interior of the spacecraft. This direct conflict between what you feel and what you see is a recipe for severe nausea. Symptoms can include dizziness, headaches, cold sweats, and vomiting, a particularly unpleasant event in microgravity where fluids do not fall but form floating, globular messes. Archival footage from early shuttle missions and the International Space Station often shows new crew members moving very slowly and deliberately, their faces pale and clammy as they work to overcome the waves of sickness. The body, however, is remarkably adaptable. Within 2 to 3 days for most, the brain essentially learns to ignore the faulty signals from the inner ear and relies almost entirely on visual cues to establish orientation. Astronauts call this getting your space legs, and once it happens, the sickness fades, allowing them to work, eat, and even enjoy the breathtaking view. It is a humbling reminder that for all our technological prowess, we remain creatures profoundly shaped by a single planet's gravity, and leaving it requires our very neurology to rewrite its most basic rules. Space sickness fades as the brain rewires its expectations, but some cosmic puzzles refuse such easy resolution, defying our most basic assumptions about how the universe should behave. Consider our own sun, a familiar ball of fire in the sky. Logic suggests it should be hottest at its blazing core and grow steadily cooler as you move outward. Yet the sun harbors a secret that turns this intuition completely upside down. The sun's visible surface, the photosphere, is indeed searingly hot, with temperatures around 10,000 degrees Fahrenheit. This is the layer we see, the source of its golden light. But if you could travel upward from that surface into the wispy, ethereal outer atmosphere called the corona, you would encounter a realm of heat so intense it seems impossible. The corona routinely soars to over 1 million degrees Fahrenheit, more than 100 times hotter than the surface it surrounds. This is the coronal heating problem, one of the most enduring and counterintuitive mysteries in all of solar physics. How can the atmosphere be so unimaginably hotter than the surface below? It is as if you walked away from a roaring bonfire and a few steps out found yourself inside a blast furnace. The answer is not in simple conduction of heat, as the near-perfect vacuum of the corona is a terrible insulator. Instead, scientists believe the sun's immense and tangled magnetic field holds the key. One leading theory points to countless tiny explosions called nanoflares. These are miniature versions of the massive solar flares we observe, each releasing a burst of energy as magnetic field lines snap and reconnect. Individually, they are too small and frequent for our telescopes to see, but collectively they could provide a constant drizzle of energy, heating the corona like a trillion invisible matches struck every second. Another compelling idea involves magnetic waves. Turbulence from the sun's convective interior sends powerful waves rippling along its magnetic field lines, like plucking a gigantic, invisible guitar string that stretches into the corona. As these waves travel upward into the thinning atmosphere, their energy compresses and dissipates as heat, a continuous sonic boom of magnetism. The most breathtaking evidence of this superheated halo is visible only during a total solar eclipse. When the moon perfectly blocks the sun's brilliant disk, the ghostly corona emerges, a pearly white crown of magnetically sculpted plasma, its delicate streamers and loops extending millions of miles into space. That shimmering veil is not just beautiful, it is the visual signature of a million-degree mystery, a reminder that even our closest star still guards fundamental secrets about the forces that shape its light and life. While the sun's corona burns with invisible heat, another world wears its inferno on the surface for all to see. The only eyes to ever gaze upon that scorched landscape belong to a machine. In the summer of 1975, a Soviet spacecraft named Venera 9 accomplished a feat of engineering defiance that remains unmatched to this day. It survived a descent through clouds of sulfuric acid, endured atmospheric pressures 90 times greater than Earth's, and landed on a surface hot enough to melt lead. And then it opened its eye, a protective lens cap popped off, and a simple scanning camera began its work. For 53 minutes, against all odds, it transmitted the first photograph ever taken from the surface of another planet. The image that reached Earth was a grainy, black and white panorama, striped with transmission artifacts, but its content was nothing short of miraculous. It showed a stark, rocky plain littered with sharp, slab-like fragments of basalt, their edges not yet worn down by wind or water. A flat horizon curved under an oppressive, glowing sky, the light diffused by the thick, toxic atmosphere. The scene was illuminated by a strange, sourceless light, as the clouds above were so thick they scattered sunlight in every direction, eliminating shadows. This was not the swampy jungle or Earth-like world of early science fiction. This was a vision of hell made real, a geological snapshot of a planet that had taken a catastrophic turn. Several other Venera landers would follow, each lasting mere minutes to a couple of hours before being crushed and cooked by the relentless environment. They sent back a handful more images, some in color, revealing an orange-brown landscape under a yellow sky. These pictures are treasures of human exploration, captured at the very limits of technology and endurance. They show a world that is utterly, profoundly alien, yet tangibly real. For a brief window, humanity touched the furnace of Venus and saw what it looked like, a panorama of ancient rock on a world that chose a very different fate than our own. Those fading transmissions are all we have, a fleeting glimpse of a shore we may not walk again for decades, a reminder that some of the greatest wonders are found not in comfort, but in the act of surviving long enough to look. The hellish surface of Venus was glimpsed for only fleeting minutes, but another world captured from the depths of space now performs a permanent backward dance. Orbiting the distant blue giant Neptune is a moon that should not exist where it is. Triton, Neptune's largest satellite, moves in absolute defiance. While nearly every major moon in our solar system orbits its planet in the same direction the planet spins, Triton does the exact opposite. It circles Neptune in a retrograde orbit, a stubborn rebel swimming upstream against the current of its planet's rotation. This single, bizarre fact is a cosmic fingerprint revealing a past of incredible violence. Triton is not a native of the Neptunian system. It is an immigrant, a captured world. Astronomers are nearly certain that Triton began its life as a proud, independent dwarf planet in the Kuiper belt, that vast ring of icy leftovers beyond Neptune, in the same family as Pluto. Billions of years ago, a gravitational encounter, a celestial game of billiards of unimaginable scale, must have sent it careening inward toward the giant planet. Neptune's immense gravity reached out, seized the passing object, and wrestled it into a new, bound orbit. But the capture was not gentle. To lose so much energy and be captured into a stable, close orbit, Triton almost certainly had to pass through a cloud of smaller moons or debris, a violent gravitational braking maneuver that would have torn any original family of moons to shreds. This chaotic origin explains its backward path and its strange, frozen geology. Voyager 2's flyby in 1989 revealed a world unlike any other, an icy sphere with a surface of frozen nitrogen, crisscrossed by cantaloupe-like terrain and spewing geysers of dark dust and nitrogen gas miles into its thin atmosphere. That activity hints at the ongoing drama of its capture. Even now, Triton's irregular orbit is being tidally forced into a more circular path by Neptune's gravity. This constant gravitational squeezing and flexing heats the moon's interior through friction, a process called tidal heating. This internal warmth could be enough to maintain a global subsurface ocean of liquid water between its icy shell and rocky core, a hidden sea kept liquid not by the warmth of the sun, but by the persistent, grinding embrace of the giant that stole it. Triton is a prisoner, but a dynamic one, its odd orbit a permanent scar from the day it was taken, and the engine that might power a secret ocean within. The captured moon Triton circles a world of blue storms, but the most complex structure ever assembled by human hands orbits our own planet. The International Space Station is not just a scientific outpost, it is the single most expensive object ever constructed. Its total price tag, accrued over more than 2 decades of development, assembly, and operation, is estimated at over $150 billion. To grasp that scale, consider that the entire Apollo program, which landed 12 men on the moon, cost about $250 billion in today's dollars, spread across a decade. The station's cost is a reflection of its staggering complexity and international nature, a project shared by 15 nations including the United States, Russia, Japan, Canada, and 11 European countries through the European Space Agency. The expense began with the design and construction of each module on Earth, from the Russian Zarya control module launched in 1998 to the European Columbus Laboratory and the Japanese Kibo experiment module. Each piece was a custom-built, flight-ready habitat or laboratory, packed with millions of dollars worth of life support and research equipment. Then came the truly monumental cost, launching all of it. Over 40 assembly flights were required, primarily using the space shuttle, each launch itself costing around $1.5 billion. Astronauts then performed hundreds of hours of intricate spacewalks to connect modules, route cables, and install giant solar arrays, a construction project unlike any other, conducted 250 miles above the Earth. And the bills never stop. Maintaining the station costs billions each year, covering resupply missions, software updates, and constant repairs to systems under assault by radiation and micrometeoroids. How does its value compare to other mega projects? That $150 billion is more than the combined cost of the world's tallest building, the Burj Khalifa, and the entire Channel Tunnel linking England and France. Yet, while those are feats of civil engineering, the station is a unique, orbiting laboratory of microgravity and a testament to unprecedented global cooperation. Its true value may not be in its price, but in its payoff, the thousands of scientific experiments in medicine, materials science, and astronomy conducted there, and the priceless lesson that in the face of an impossible challenge, humanity can build a home together in the void. That $150 billion home in orbit is a testament to our ability to reach out, but sometimes the most profound souvenirs are the smallest ones brought back from the farthest places. In the quiet suburbs of Sagamihara City, Japan, stands an unassuming stone monument. It looks like many others, a marker of a local achievement, but this one holds a secret that connects this patch of earth directly to the void. Embedded within the polished granite is a tiny, dark speck, smaller than a grain of sand. This speck is a piece of an asteroid named Itokawa, and its journey here is a story of brilliant engineering and a desperate against all odds rescue. The saga began with a small spacecraft named Hayabusa, Japanese for peregrine falcon. Its target was a near-Earth asteroid, a rocky, potato-shaped object only about 500 meters long. After a 2-year cruise, Hayabusa arrived in 2005, but nothing went according to plan. The mission was to fire a small pellet into the asteroid's surface, stir up dust, and collect the fragments in a sample return capsule. The first attempt at landing was a disaster. The spacecraft tumbled across the surface, losing communication and leaking fuel. A second attempt seemed to go no better. Ground controllers were certain the sampling mechanism had failed to fire. With its systems failing and its fuel leaking away, Hayabusa was dying, yet the team refused to give up. For weeks, they fought to stabilize the crippled craft, using its ion engines, never designed for such a task, to begin the long, slow journey home. It took 3 more years of nail-biting effort, but in June 2010, a charred capsule streaked through the atmosphere over Australia and parachuted to the ground. When scientists in Japan finally opened the precious container, they found, against all hope, a sprinkle of microscopic particles. Hayabusa had not failed. During its chaotic touchdown, a few grains of asteroidal dust had bounced into the collection horn. These were the first samples ever returned from the surface of an asteroid. One of those priceless grains was carefully set into the Sagamihara monument. To stand before that stone is to be in the presence of something older than our planet, a speck of primordial rubble from the dawn of the solar system, now a permanent landmark on Earth. It is a quiet, powerful symbol, a piece of the cosmic wilderness brought home and anchored in our world, forever linking a city park to the silent, sunlit rock from which it came. That microscopic grain of asteroid dust now rests safely on Earth, but other microscopic life forms, when taken off our planet, can transform into something far more dangerous. On the International Space Station, inside sealed protective containers, scientists have cultivated a quiet and unsettling discovery: certain bacteria, including common strains like Salmonella and E. coli, do not just survive in the microgravity environment, they thrive and become stronger. Experiments have shown these space-traveling microbes can increase their virulence, their ability to cause disease, by a factor of 3 or more compared to their Earth-grown counterparts. Images from these studies are eerily beautiful, showing intricate, delicate colonies of bacteria blooming in petri dishes. their patterns subtly different from those grown on the ground. But this beauty masks a significant threat. The reason for this transformation lies not in some exotic space radiation, but in the profound stress of the spaceflight environment itself. For a bacterium, floating in microgravity is a state of constant, low-grade alarm. The absence of gravity's gentle pull disrupts the normal flow of fluids around the bacterial cell, altering how nutrients and waste products move. The cell perceives this as a form of starvation and physical stress. In response, it activates a cascade of genetic switches, turning on genes associated with survival under duress. Many of these same genes are also linked to increased virulence, mechanisms that help the bacterium invade host tissues and evade immune systems. It is a classic case of a survival adaptation having a dangerous side effect. The bacteria essentially arm themselves for a harsher world, and in doing so become better equipped to attack a human host. For astronauts on long-duration missions, this presents a clear and present danger. A simple infection that might be mild on Earth could become severe and harder to treat in space, where the immune system is already weakened by the stresses of microgravity. This research, however, is not just about managing risk, it is a revolutionary tool for understanding disease. By studying how bacteria change in space, scientists are identifying the precise genetic pathways that control virulence, pathways that are often hidden or muted in Earth-based labs. The unique stress of microgravity acts like a spotlight, illuminating the core machinery of infection. This knowledge is already helping researchers back on Earth develop new strategies to combat antibiotic-resistant superbugs and create more effective vaccines. The silent, floating colonies on the station are teaching us that the battle between humans and microbes extends into the final frontier, and by watching them evolve there, we are learning how to win that battle here at home. The silent, floating colonies of bacteria remind us that life adapts to survive, but our own species has chosen a different kind of adaptation, reaching out not just to understand but to be understood. While the Voyager golden records are passive time capsules drifting with the probes, humanity has also sent deliberate, targeted shouts into the cosmic dark. The most famous of these is the Arecibo message, broadcast just once from the giant radio telescope in Puerto Rico in 1974. It was a ceremonial transmission celebrating the telescope's upgrade, but its target was anything but ceremonial. The message was aimed at a dense ball of stars known as Messier 13, a globular cluster containing nearly 300,000 ancient suns 25,000 light-years away. The message itself was a masterpiece of symbolic compression, just 1,679 binary digits, ones and zeros, arranged in a precise 73-row by 23-column grid. This number was chosen because both 73 and 23 are prime, a mathematical clue for any potential recipient to arrange the data correctly. When decoded, the graphic reveals a series of icons. It begins with the numbers 1 through 10 in binary. Then it displays the atomic numbers for the elements that make up DNA, phosphorus, oxygen, nitrogen, carbon, and hydrogen. A double helix follows with a vertical bar indicating the number of nucleotides in our genetic code. A crude human stick figure is next, with a number showing our average height beside a diagram of our solar system, with Earth offset to highlight its significance. Finally, a simple sketch of the Arecibo telescope itself with its diameter given. The entire transmission lasted less than 3 minutes, a fleeting pulse of focused intelligence hurled across the galaxy. The timescales involved are humbling. The message will take 25,000 years just to reach the cluster, and if anyone is there to hear it and decide to reply, another 25,000 years would pass before we could hope for an answer. We are planting a tree whose shade we will never sit under, a gesture of hope across an abyss of time. This act sparked and continues to fuel a fierce philosophical debate. Is it wise to announce our presence so boldly, Some scientists, like the late Stephen Hawking, cautioned against it, comparing it to the Native Americans shouting greetings to Columbus's ships, a naive invitation that could lead to catastrophic consequences if a more advanced and predatory civilization were listening. Others argue the universe is likely so vast and quiet that our tiny signal is insignificant, a single firefly blinking in a hurricane. They see the message as an essential expression of our curiosity and optimism, a declaration that we are a species that looks up and wonders who else might be looking back. The Arecibo message is now a cultural icon, a pixelated postcard from a young technological civilization, its journey just beginning. It asks a question we may never hear answered, but in sending it, we answered something profound about ourselves. We are the species that, against the silence of eternity, chose to say hello. From a single shout across the stars to the silent growth of bacteria in a tin can, these 30 glimpses are more than just trivia. They are the brushstrokes of a much larger portrait, one painted in equal parts by human courage and cosmic chaos. We have journeyed from the first fruit flies to the final graveyard in the sea, from worlds of diamond to storms that could swallow our own. Each fact, in its own way, reveals a universe that is profoundly weird, endlessly creative, and humblingly vast. They show us that exploration is not just about reaching new places, but about being changed by them, whether it is our spines stretching or our very understanding of physics being validated by a hammer and a feather on the moon. This collection is a testament to our stubborn ingenuity, our drive to solve problems with golden spheres and recycled water, and our deep need to send messages, however faint, into the eternal quiet. It reminds us that for every question we answer about the cosmos, two more, even stranger ones, seem to emerge from the darkness. So what does this all mean for us here on this pale blue dot? It means we are participants in a story far grander than our daily lives suggest. We are the creatures who map the retreating moon, listen to the radio whispers of Jupiter, and dare to imagine life in an icy spray from a distant moon. Our curiosity is the engine that turns the unknown into the wonderful. The universe is not just out there, it is in the lessons learned from every failure, every near disaster overcome, and every tiny, glittering fact we bring back home. Now, we would love to hear from you. Which of these 30 facts reshaped your view of the cosmos the most? Was it the backwards day on Venus, the lost tool bag, or the silent song of space itself? Let us know in the comments below. If you enjoyed this journey through the weird and wonderful, be sure to subscribe for more deep dives into the mysteries of space. And always, no matter where you are, take a moment every now and then to simply look up. The greatest story ever told is still being written, and you are here to read it.